So now we are going to see the interesting part, which consists in consuming messages sent by the train with the positions and looking, searching for nearby infrastructure with geosearch queries on the MongoDB database where we have all our GeoJSON shapes. So for this, I'm still using a real-time route from Talend, and this route is waiting for any messages coming from PubSub, Google PubSub, and when it receives a message with the train positions, it will trigger a job which will send back all positions of infrastructure. If there is any infrastructure found, it will send another PubSub message with an alert saying this is the train positions, these are the nearby infrastructure. If it does not find any infrastructure, it will send no message, basically do nothing. So this is the job, Talend job, which is called and inserted in the route when Talend catches a PubSub message from the train. So there is here a first step that will extract from the message the position of the trains, and we will set that as global variables that we will use later on. So first step, we have to convert the payload from the PubSub message to a string, and then we will use this very cool component from Talend to extract JSON fields from this string, so to map each field. And finally, we do write this, as I told you already, as context variables because we need to reuse it further when we build the query against MongoDB. So next step, after connection to MongoDB, we are going to use the MongoDB input in order to build the query that will fetch infrastructure, GeoJSON. So it's a near query, it's a geospatial query, and you can see we're using the context variables here, latitude of longitude sent by the train initially as the PubSub message. And you can see here, so the near operator is only usable in MongoDB against an index, a geospatial index that has been built. That's what I showed you in part 1. And so we're looking for any infrastructure that's located within a distant range. So in my case, between 1 meter and a maximum that I think I've put to 10 meters. So to be sure, 100 meters I put. Okay. So it will give back, if there are any, all the infrastructures that are in the database. So as we saw, level crossings, stations, tunnels that are within the range of the train. And then that's fairly simple. We are getting the query and extracting fields that we have back from MongoDB. what's the type of infra, what's the city, latitude, longitude, the network number, and some other data here. And then we're going, after a quick log, so to debug, we're going to map this to a new JSON message. So we're going to transform this data so it's intelligible for humans, because we're sending this to another message that will be probably put into an analytic tool. So here you can see the Talend mapper, which is drag and drop, and in which you can also do a little bit of conditional mapping in order to build cool data that's understandable by end users. So also depending on the infrastructure that's found, I'm doing some specific mappings. So now once the mapping is done, then I will, so I'm sure it's not the best practice here, but I will filter out when there is no alert. And when there is an alert, I will build a JSON message with the right JSON component the good way, so it can be sent back to my real-time route, and either so this is where we could send alert message if we have an infrastructure with this component that's writing basically a pop-up message, which publishes a new message on an alert topic, and this is obviously what we are going to read and write into an analytics database or an alerting system if needed in a last step. So we're actually now running the route, and at the same time we are going to run the train position simulation. And as you can see, yes, we receive the train positions. So sometimes the train positions does not generate any alerts here. I can see it through the logs. So you see this is empty. There is no infrastructure around the train positions. But sometimes, hopefully in a few seconds, we come across here a station, Meriel station, which is not far from my house. And you see here there is an alert generated, an alert message generated saying, yeah, I'm near a station. So all this is done thanks to geoSearch, real-time geo queries on MongoDB. So yeah, we achieved what we wanted to do, and now the next step will be to read those alerts real-time and write this into a streaming BigQuery database, so to generate real-time dashboards. See you next.